Agenda for tonight is, you saw it on the thing, we're going to start off with a little bit of not everybody in here is part of AEC industry, architecture, engineering, and construction. So we're going to do a bit of a background to how we in this industry have approached the digital aspect of things. Then our node is going to go over what is the BHoM, a very high level and detailed review, let's say, of what it is that you need to know when you walk out of here today about the BHoM. And then we're going to do a hands-on session where we can actually show you guys kind of how to use it and potentially give you some ideas of how you can contribute going forward. One of the key pillars of tonight, if you walk away with anything in your head, just remember the BHoM is a common language. The AEC industry is a very horizontally integrated system. Everybody's got different disciplines, and communication in the machine is a very difficult problem because we do not have any common language. The BHoM, at its very core, puts that in perspective. We can actually now have a common language that we all agree on going forward because of things like the BHoM. So, just a real quick introduction. My name is Dimitritris. I'm Asia Computational Projects Lead here at BHoM. This is Dr. Arnaud de Klerk. He's our Global Computational Framework Lead. So he's one of the main architects of the BHoM itself. He's not part of the AEC industry until he came here. He's a computer scientist. I'm a structural engineer by training. So I'll give you some background for those of you who are not in our industry. One of the things that I remember very specifically in my first job was this cartoon posted on my wall in my office. And the more I'm in this industry, the more I kind of understand this cartoon. Because this cartoon kind of epitomizes for me, how we are perceived in all other industries. We're perceived as an ass-backwards industry that doesn't get things done and is famous for being unproductive and very lowly digital. Now, it's not easy to build cities. It's not easy to build buildings. If it were easy, everybody would be doing it. But the way that we approach the digital era and things getting more complicated in our world, our approach to data has been woefully behind people in other industries. So let's go over how our industry has handled data. Because we're in the business of creating things, objects that you can actually go and touch. Not just moving money from one pocket to another, but really things that you can actually are tangible. So how do you create something before it's created? Something. Well, back in the day, for many, many, many years, the only way to describe something, tangible thing, before it was actually there in reality, was to actually make a small version of it. That was the data. The famous story of Brunelleschi, one of the original master builders, who you'd go to and say, Brunelleschi, I want that. He'd go, well, before you get that, you get a bunch of turnips that I quickly carve up and tell you what to make, and we eventually get to that. But first, the data of the building before it exists is a turnip, or some sort of physical model. Then some guy, Alberti, came along, and he was over here. He's like, yo, gotta go on drawings. We can draw stuff. It's way easier. Let's go to drawings. And he say, oh, but we have 3D objects that we're working with. That's okay. We'll just draw them all on different orthogonal projections, no problem, right? And then that's the way we continued into the future. And we could do some pretty dope stuff with just drawings, okay? Mr. Guastavino over here could really kick ass at making staircases without any computers at all. So it's not to say that you can't do awesome things without a computer. But for many, many years, the data in the industry went from turnips and physical models to some would call just dirty marks on paper. But then computers came along. And computers, our industry started off backwards because instead of trying to reinvent the wheel, what we did is we took those dirty marks on paper and we made the same dirty marks in digital space. So we didn't change how we were doing things, we just changed the medium in which we were doing them. So we stepped into the digital industry with CAD, computer-aided drafting, just drawing stuff. Again, tangible objects being drawn instead of actually being modeled. Now, some people in this room from the AEC industry kind of go, oh, I know what's coming next. It's BIM. The BIM, the big 3 words. So if you're not in the industry, I just want you to remember, building information modeling. If you say the letters BIM, B-I-M, you are Steve Jobs in the AEC industry. You will be put on a pedestal as far as, wow, that guy, he really knows what's going on. Because at the end of the day, it's the best thing that has come out in our industry. No one else has tried to do better than this. Now, we forget that a lot of times in the industry, that these are the main things that BIM was supposed to be. That you represent the building or whatever you're doing, the city, something that's physical, you represent that as it is, that it's meant to be a shared common language between everybody, and it's just a database full of objects. So those three things. Present the thing in digital space as it will be in reality, make it something that allows us to communicate with each other, and make it a database of all the objects that are all interconnected that come together to make our built environment. That got forgotten right away, and the reason why people still sit here and say, we're going to get to BIM, we're eventually going to transition to BIM, is because of one big thing. When you actually talk about the implementation of BIM, you're not talking about all of those three things, which everybody would agree is pretty good. You're talking about, and by the way, this is Wikipedia, so it's definitely true, often but not always in proprietary formats. Because when I say BIM, everybody in their head, in the AC industry, mostly thinks of one of these two, maybe some other ones. But really, you're thinking, what software do I need to buy to be able to do what I want to do? Now, this is where the fallacy of BIM, in my opinion, comes in. Because there is no way in an industry where every city, every road, every sewer system, every building is somewhat bespoke, that we could ever have something that is completely a shared knowledge, completely allows us to store all our objects, and completely allow us to define things as they will be in reality. No one software house can do all of that for one discipline, let alone for all of them. So the fallacy is that these guys right here could ever define for us a platform that allows us to do all of those things at once. And that even they will admit it, because they have given us backdoors to their software. And that has been the next logical progression of this stuff, where you say, now you have that one guy in your office who says, yeah, this software sucks at this, but if you give it to Emilio, he can make something that looks like this, or something that looks like this, or maybe even something that looks like this, to fill in the blanks that the software company couldn't give you or wouldn't give you. Because why would I do that? I have a monopoly on that particular sector. I'm not updating my software. You deal with it, right? The next logical step, as far as we see it, is mass participation in this field. And as part of that, the BHoM represents the big shift when we go back to saying, what is it that would be really good? Again, let's represent things as they are digitally, as they will be physically. Let's have something be shared so we all speak a common language. Again, common language. And let's have it be something where we all have a database where we can understand what are these objects digitally just as well as they will be physically. We will take out of this the proprietary aspect and make it open source. When you do that, the conversation changes. We stop talking about software and we start talking about how do we make our built environment with digital tools. So that is a brief introduction to the AEC industry and a lead up to what our node now can tell you about the BHoM.
Right. Well, this is going to just be a very high-level introduction to the BHoM, right? I don't want to bore you with like complicated coding stuff. But in terms of the reason why, I mean, Emilio gave a pretty good introduction on that, but the initial plan with the BHoM was really just creating an object model, a common language. And the reason is, sure, we've moved to the digital age, but we're still having to play with those tons of different softwares. And we have no way to link them with each other. Sure, Revit might pretend that it's a solution where just one package and you do everything in there, but that doesn't work either. So what we end up doing is each of those softwares is saving us time, but then all the time that we've saved, we're losing it when we actually have to take the data from one piece of software to another piece of software. So we're not really getting that much. And all those links that we have to do, most of the time, it's just people just having one program on one screen, one program on the other, and basically duplicating stuff. So that's not good. Some people have done, little scripts here and there. We've seen that for years where people have, claimed they have a translator between software X and software Y. Great, good for them. But then look at the number of translators that you have to do everywhere. The BHoM is actually solving a problem that is very, very dumb and very, very simple. It's saying, instead of doing all those translations between all the softwares, why don't we just do one translation between that software, just a common language? It's such a dumb idea. Like, it's not revolutionary at all. It's just like a very, very simple thing in terms of saying, we just need that one common language so we can just work all together. And then when we exchange data, we just need one guy that has done this link between the BoM and whatever tool. And then we can send it to everything else that has already been connected to the BoM. And the beauty of it is that it's not just about connecting software, it's also about connecting people, right? Because if we have a common created language that we all agree on, not just within one discipline, but across disciplines, then we can actually communicate with each other. Because what I've noticed in BH at least, and I suppose it's like that in the rest of the industry, is that we just don't have problems of getting information from one software to another. We have problems with getting information from one team to another. And that takes as much time as getting from one software to the other. With this, the idea is, ideally, is to have this common language where we use the same objects. If one team is adding information to an object, can send that to another team, and sure, the other team will add other type of information, but the base, the support of that object is still going to be the same. And that's the idea of the BoM, is really just this common platform that has been discussed and agreed and created among a group of people. And this is why it needs to be open source. This is something that is going to keep evolving. This is something that is not just made by a bunch of software developers that have no idea what kind of object you need, right? And it's the same for me. I'm not a software engineer. I don't know what kind of object you need on an everyday basis. So I'm not going to decide for you what you need. I'm going to let you decide that. And so that's the idea, right? It's what I've said over and over. And I just want, I want to hammer that in your head, is really just, it is created by the community. It is created by the community. And once we have that common agreed language, we can just all work together. And it's all nice and dandy, but the problem is, it all goes down to code, right? It's very nice that I'm saying you guys are in charge of deciding what object you wanna play with and what are the properties of those objects. But then if I tell you that you then have to code in C# or C++ or whatever language, that's not going to work. You have better things to do than learning to code complicated languages. So we've made it in a way where we made it as simple as possible. And even if you guys don't actually code, and you might not understand what some of those keywords are meaning, like namespace and class and all those kind of stuff. One thing that is very, very clear for everybody is that here's a circle, right? And a circle, I want for a circle to have a center, a normal, and a radius. And what is a center? It's a point. What is a point? Well, it's 3 values. It's x, y, z. Okay? You might not understand what double means. Double is just a number. Okay? So we have a point here that we've just all agreed are just x, y, z values. And then we can start using it to make more complicated objects. And that can build up, right? We can actually have more useful objects, like a speaker, for example, and that will have a lot more properties. Some of them, again, some of the things that you might not necessarily know what a dictionary means. But the good thing with this is that we've actually taken to a level where you have to learn very, very little to actually be able to write some C#. It's still C#, right? But it's actually as far as C# as it can be. It's literally something you could write down in Word or in Excel, and then some software developer could actually convert it out. We're actually planning to do exactly that, to have something where you're writing your properties, your BoM object in Excel, and it will automatically generate the C# code for you. So you don't even have to know C# at all. Because that is to a point where it's so dumb and so simple that it doesn't actually need to be written in code at all, right? And that's all we have. The BoM is actually this massive library of tons and tons and tons of object definition. And that's all there is to it. So that we get to a point where engineers can actually just write down definitions of a BoM object, even just during a meeting, agree on what are the properties of an object, and move on. And just, send it to a software developer to just write it down, send it to the code, and then it's done for good. So, I've talked about the BoM quite a bit, so I'm going to shut up on that one. But what is the rest of it? It's good to have a common language, but we still have to deal with computers. How do we go from just a common language to something that we can use to then connect computers and programs, right? So we need something that we call adapters, and I'm going to come back to that, which is basically the program that takes the BoM and translate the BoM into whatever language that software needs. If it's Revit, Revit has defined object in a very specific way. We need to have a translator between what is a beam in the BoM and what is a beam in Revit, okay? And we need the part of the code that is actually saying, if I have a BoM object here, I need to send it to Revit so that Revit creates that object. So that's probably the most technical advanced thing. But again, you do it once, you never have to do it again. So for that, we already have in BH, we have, I don't know, we probably have adapters for over 20 different programs already. Yeah. So, you know, there's a limited number of programs you have to deal with. Once it's done, it's done. You might have to add a few more BoM objects in the future, but that's it. So that challenge is actually taken care of for most of the programs already.
And the framework is there for everybody, for whatever software you want to use.
Exactly.
So we've taken care of the framework such that if you want to bang together something for CATIA, the infrastructure's there. Just come in there and get done with the CATIA specific stuff, and then CATIA now exists in the BoM as an adapter.
And I'll come back to that, but the adapter, there's a lot of things that are complicated when, you know, like you're pushing objects to your external software, and there's objects already there, like how do you merge those things together, all that kind of stuff. That we actually have taken care of. So there's a specific part of the code that is common to all the adapters, and is actually taking care of solving those problems of how do I merge information that is being pushed to the external software and the information that is already there. So the job of the people writing the adapter is actually a lot simpler than that. It's literally just the part of doing the translation and opening the channel with that software so we can push things. But it's not all, right? If we have a common language, as I said, we want to link the softwares, but we also want to link the people. And we've had it for years. 10 years ago, we already had people writing scripts on their computer and saving a bit of their time. The problem is that that script was staying on that person's computer, maybe shared with a few people, and then when that guy was leaving the company, that was lost, right? So the idea here is actually to tap on the fact that we have the BoM, to also have a place on GitHub. Sorry, GitHub is where everybody puts the code online, okay? And we didn't invent GitHub, just FYI. Here, again, the idea is saying we already have the definition of the object you're going to manipulate. So if anyone is writing a bit of a script, we can actually save that as well online on GitHub, because all the objects are going to be the same. If someone else has the same object and need a similar algorithm, the solution is already there. It doesn't need to be reinvented over and over. Because, again, the language is the same. It's not, oh, the algorithm and the logic is the same, but you're manipulating objects that have property named differently than me, so I can't use that. No, the language is the same. I said I would shut up on the BoM, but I can't stop coming back to that, apparently. And then the UI. The good thing is because all those things are common and created and actually controlled within the BoM environment. The beauty of it is that there's actually nothing to do on the UI, pretty much. Well, I had to do a bit of work at the beginning, but now it's done. Every time someone adds something on the BoM, every time someone adds an adapter, every time someone adds something in the engine, there's literally no code needed on the UI. I'll show you that in a second. So actually the UI, except for the moment where we need a new plugin for a completely different UI. And for the moment we have Grasshopper, we have Dynamo, we have Excel, and we have Chrome, believe it or not. Although that one is not open source yet. There's nothing to do. When people add code, they recompile their code and it's automatically available in the UI. So I've talked about a bit about the engine, right? And yeah, sure, the BoM was not that scary. You could do that in Excel. But the engine is still writing code, right? So that's a bit more scary. Well, we made it as simple as we can. So what is actually the most difficult thing for people when they have to code? It's not actually writing a little script, writing a little function. What is complicated is when they have to worry about the code infrastructure. You know, they go in Visual Studio and they have to put all those other pieces of code that have nothing to do with the little script they want to write. They have to play with the UI. They have to make sure all those classes are working nicely with each other, even if they, you know, you might even not know what a class is. So the idea here is that we've taken it down to a level where you just write very, well, they can be long, but you can write a little scripts like you would do in a C# component in Grasshopper or in a Python component in Dynamo, right? If you can do that level of coding, the BoM is actually at your level, right? Because it's just a ton of functions that are just sorted in files by name. So here we have all the ones that are called distance for the geometry, for example, right? And it's just a ton and ton and ton of functions. They're organized in a nice way. I'm not going to go into that right now because it's going to be too long for the conversation. But we've tried to make it so simple for you to just say, I need this little piece of script. I just need to add one function or one file in the engine and write my thing. and it will be available in the UI for everybody already. We actually, in a few months, we're even going to push things further, where we're going to convert C# scripts, or even Grasshopper scripts actually, not C# scripts, Grasshopper scripts into C# directly. So you will not even have to open Visual Studio. You will just translate whatever you've done in Dynamo or in Grasshopper directly into C# code, and that will be part of the BoM. So that way we're trying to lower the threshold so that everybody can participate and keep doing their job instead of spending hours and hours learning complicated language they don't really need for their job, right? And the UI, I've said, the UI is taken care of. And I'm not lying, this is basically, if you install the BoM, this is the components that we had 6 months ago, this is the components we have today, this is the component that you will have in 6 months in the future. That's not changing. Because the idea is that once you pop one of those components in the canvas, and those components are just helping you to just organize the code. So if you do a query on an object, for example, so you're asking information about a specific object, then all you have to do is you pop that empty component on the canvas, you right-click on it, and then it shows you, it mines automatically the code and shows you every little function that is already available in the code. And when you select one, it will turn the component into that function. Okay? And that's the idea here, right? Is that the functions in C# are actually not that different from a component in Grasshopper. A function is simply a bunch of arguments that you have as input, and it spits out one output. So if you understand that, if you can do a little bit of C# component in Grasshopper or Python in Dynamo, you're pretty much ready to do some coding and some contribution to the BoM. Okay? And then again, everything will just add itself into the UI. There's nothing to do on that level. And because we have that very small layer between the code itself and the final result in the UI, right? Everything that is a function in the code becomes a component in the UI. There's actually very little difference between what even happens as IntelliSense in Visual Studio to what would happen when you search for a component in Dynamo, Grasshopper, or Excel. So if at one point you start as a user in Grasshopper, and at one point you feel like you're ready to start going and contributing to the BoM, to the C# code, I mean, you know, to actually open Visual Studio and write some code, you will already be at home because the infrastructure, the way things are organized in the UI is exactly the same way things are organized in the code. So with all those things, we're simply trying to lower the threshold, to increase the possibility for mass participation, to make sure that the engineers can stay in the engineering mode, even if when they're contributing to the BoM. Okay? And the adapters, which is easily the most complicated part. When you want to create an adapter, if you're a software developer, it's not difficult, especially nowadays with the way BoM is organized things. But it's still going to be the most complicated part of the code, simply because you have to link with an external software. You have to link with an API. But we try to make things as simple as possible in making most of the decision for you. For example, the user interface for every single adapter is exactly the same. There's only 6 things you can do with an adapter. And that's actually covering everything you will always, hopefully, I hope I haven't forgotten anything, but that's the 6 things you will always have to do with an adapter. Pushing some data, pulling some data, updating some stuff, deleting some stuff, even moving things from one adapter to another, and executing some commands, like do this calculation, like structural analysis or whatever. And this means that actually, when you are a user, the interface for using things that are so as different as a Mongo database, sockets, which is just something where you just use your hardware to send data between different parts of your computer, Revit, Jesse, all those ones have exactly the same interface. And actually those ones are exactly the same component. You can just literally plug those 4 into the same component and it will just send it to those 4 softwares. So again, it's trying to lower the learning curve, trying to make those things as simple as possible, both for the users and for the contributors. So I'm just going to finish with a few examples. There's been a ton of different videos online with people that don't necessarily use the BoM, but have connected softwares, have shown like, oh look, I'm doing this thing in Grasshopper and it appears in another software, woohoo. So I'm not going to show you that. But I want to show a few ideas of the things that are a bit different that you can also do. I mean, the one that is probably the most obvious, and other people have done before, is that you can also link UIs now very, very easily. So I mentioned sockets before, which is, again, not going into details, but it's a way for you to communicate with the other computers on the web, but also programs on your machine. And because we have an adapter for that, you can actually link, I mean, here I've done Grasshopper and Dynamo, but you could do it with Excel, we've done it with Chrome, we've done it with different softwares. You can link your different BoM UIs and start working with those different softwares as if they were one, pretty much. Instead of having a wire that just goes from one part of Grasshopper to another, it becomes a wire that goes from Grasshopper to Dynamo, for example. Another example is actually using Chrome. I've mentioned Chrome a few times, but one of the things I found the most difficult, to be honest with you, working in Grasshopper, is that the only way you can visualize data is in 3D. But there are situations where the 3D is not helping. You need some decent graphs like you would have in Excel, and you need graphs that you can interact with. So you see things in a different view, and you can use that view to select the things. In that view, it's very clear what you need. So if you could just select that piece and say, that's what I need, and just feed it back straight away to Grasshopper, so that those elements become available as BoM objects, become available in the 3D view, then it actually speeds up your work. In this case, what we're looking at is a cable net design for a roof or a stadium. Okay, and so the results we're seeing here are actually the results that we get from JSA, if I remember correctly. And so it's looking into things like tension ratio, torsion ratio, yeah, all those kind of fancy stuff. I know, I'm getting good at this stuff. And so the idea here is that was one attempt on the sizing of the cable net, right? And some of the numbers here were over 80% of utilization. So it becomes very, very clear here. We have different type of utilization ratios, right? And quite a few of them were already quite good, but some of them were definitely too high. The good thing with that is that you can literally just select, and it was beautiful. I watched actually the guy working with this tool. He would just run a simulation in JSA, and then the data would just come back directly into Grasshopper, and then he would select the pieces that were definitely too problematic, see what part of the cable net was failing, and it would be like, oh, that's it, I know what I need to do. He would go back to engineer doing some resizing of his cables, rerun a simulation, and then have a different graph here and cycle like that. And he would stay in the engineering mode, except for the time where he has to wait for JSA, obviously, to do the computation. But he would literally stay in engineering mode and do like 10, 15 design in just a few hours, which normally is the kind of things where you just keep shoving data around, but you're not staying in engineering mode, right? And then one that is more for fun than anything, to be honest with you, but that was a nice challenge to do, is to do VR. And VR, to be honest, is interesting for a lot of people, but I found that most of the cases is just the fancy stuff that is wasting time. But in this case, it was actually quite nice because I had no idea what eyeball line was in Stadium. So for those who are not, and I try to explain the best I can, but it's basically just like in a game, like the players would shoot the ball and stuff like that, and making sure that you can always see the ball, even if it's on the highest level. So usually there is in the drawings, there is just literally a line saying, okay, that there should be nothing under that line, or people will not be able to see the ball. Okay, and so here this is what we represent with this purple surface. And so here we are in VR. I think that this was the Unreal game engine, and then I had two things on my screen that you'll see in a second. It was just in Grasshopper, but then I have a view of the stadium in Rhino, and then I had just one slider that would change the height of this tension ring. Is that, yeah? I still haven't done a mistake, that's amazing. And so that's Al, that's my boss. I would just moving around, so I would click on a point on the 3D drawing here, and that would move him in that location. And then I could change the height of the tension ring, and that's what you see here. And by just changing this, the whole tension ring would just go up or down, and he would be able to tell me, yes, this is perfect now. Obviously, as an engineer, you don't need that. It's a fancy tool that you could do in 2 minutes for the calculation. But to communicate the information to the client, that's really, really helpful. Even for me, I had no idea he was talking about that, eyeball line and stuff like that. But just being in the game and actually seeing that and understanding this is why I'm spending more money, so that if I'm sitting on those top level seats, I can still see everything correctly. And that was quite fun. We haven't done a ton of projects in VR, but just the fact that we had the BoM, and it only took a few hours to just create an adapter to the Unreal Engine. It was not something where we had to make a very heavy decision, are we going to invest in VR? No, it was just like, well, let's use the BoM, create a quick adapter, you know, that was honestly, like, most of it was just like quick code, like written like really badly. And that was it. Like, we had a session where we had a bit of fun with it. And we moved on. I think other people have used the VR quite a few times, like really cool stuff actually, like putting people in wheelchairs and using the remote to have to walk around the building, well, not walk, but like, you know, wheel around the building. And there's been quite a few things where you really need to be in the situation to understand what it means for the people that will be in the building. And just being able to do something where we didn't have to make a huge decision in terms of we need a massive budget to do VR, but just saying like, yeah, let's throw in a quick adapter and then we can move on. That was pretty cool, I think. So I'll let you just finish and wrap it up.
Yeah, right. So just to wrap it up, because we could talk about this all day. There's 2 rules. There's a little bit of a new era, so there's got to be a couple rules. One is take responsibility. So I kind of have to go back to where we were before. These guys took responsibility for their data, all right? They were actually in charge. They didn't have a hierarchy for their data that started with some software Goliath, and I put Rhino in here. I like Rhino, but I don't want to sound like an Autodesk hater. Okay, any software. If you have to go to a software to define something for you, that's it. Like, you got to take it or leave it, right? You got to pay the licensing fees whether you like it or not, right? So the thing is our node shows you that we have a definition. We've gone as pedantic as defining a circle, and we've gone as pedantic as defining a point, because we own that shit, okay? And when you use the BHoM, you got to take responsibility. You go all the way to bedrock. Until you hit numbers, you don't own it. And we don't want anybody else to own this. We want the collective to own the definition of the objects. And the other thing is remember, we're coming off an era where we've been taught to think of things a certain way. You have been predisposed to think of things as Autodesk wants you or Rhino wants you. So please do not come to these conversations thinking someone's going to take care of it for you. But equally, don't come thinking that you can impose your particular software biases on the BHoM or even your discipline. We check our disciplines at the door when we've been working on this stuff to try and get to, well, what is a point? Well, a point has nothing to do if you're an architect or an engineer or some cities guy. What is a point? Full stop. To anybody, the most agnostic definition that we can come up with is the right definition. Once we get that down, as our node says, then the communication between different softwares and everything becomes very easy. And that's the key. The key change with the BHoM is it's a common language conversation first, and then software, rather than where our industry's been the last 20 years, where it's just been about who's on what software, and if you're not on this software, then you're a loser, right? And if you're on this software, you must be really smart. So that's it for the presentation. These are a couple key links. Our node probably will show this in a bit here, but the wiki page for this open source project is, very detailed. We wanted to make sure that it's open to everybody, and for that reason, the wiki page is very detailed. So please do yourself a favor. You can download it, but before you just jump in and hack, it probably is worth the 5-10 minute read to do that. So before we jump into just the next portion of hands-on and showing a couple other things to everybody, does anybody have any questions going forward? Can I have my water, please?
Yeah. So show you we're not lying. This is the homepage for the wiki, and that's a bit small. So I'm just going to go down. Hopefully that will be a bit. This is links to all the pages that we have written right now, and as you can see, there's all the sections you get in cover, from the getting started to even just using GitHub Visual Studio to how to contribute to some basic guidelines. There's probably a lot of holes in there. There's probably some things that are still not explained simply enough or whatever. But we've put a lot of energy there, and I think this is one of the things we pride ourselves to have done. Is most of the open source projects have pretty rubbish documentation, and here, because we're trying to be accessible to a lot of people, we want to make sure that it is understandable from the get-go. You might still hate us a few times or pull your hairs out, thinking like, I don't understand how this stuff is working. But this is one of the reasons as well. I want to stress that out. This is why this is open source, and this is not BH as well. I want that to be really, really important. This is the BHoM is building an habitat. Okay, BH is confusing, and we have to play that. At one point you need some funding, but this is an open source. On camera. But this is an open source project. The idea of this is to change the industry, and this is why lowering the threshold, making it accessible is so important, because if you want to have people on board, it needs to be something that people can understand as easily as possible. It's still coding. There's still going to be some part that's hard, tricky, but we've tried to make it for at least the day-to-day, the object model and the engine. We've tried to make it so that it's something you can pretty much do on a daily basis without slowing you down. And this is why this is why it's open source. This is why we need a community. This is a project that cannot work, that cannot be curated, that cannot be agreed upon if we don't have a very large community. It's fine, it's been working fine in BH, but I think that there's a long way to go on the engineering side, just because it needs a wider community.
And you keep going, because we're an engineering firm. At the end of the day, you go into the object model right now, and there's an architecture object model.
Pretty much empty.
It has grid and level.
Yeah.
So there are things that we are not qualified to start having the discussion on of what is this, that, and the other, right? So, and that runs deeper than architecture, and then there's construction, and then cities and whatnot. That really all of these things, we cannot rely on a software company to have all those conversations. It really comes down to who's going to step up and take responsibility and make it something that happens. Come on.
I do have a question. Well, first off, I must say that I think this is really great. I love the presentation. I love what you guys are doing, and I particularly want to commend you for open sourcing it. I think that's just great. I do have a couple questions. I'm not going to go through all of them, but I think one important one that I have is I don't quite understand the architecture of this thing. So you do have an object model and you have an engine. That how do the objects get transported to the engine, and where does that sit? Is that like a cloud-based thing?
They're not transported. So if you look at it from the perspective of a user, in Grasshopper, you're already working with objects. If you think about it in Grasshopper, when you work with Rhino objects, with geometry, right? You're working with points, curves, surfaces. Those are actually already objects. And so that's what goes through the wires. And you could compare it to the OM is basically those Rhino objects that you're manipulating already today. And the engine is the components that you have available in Grasshopper. So,
right, so if I send objects from Grasshopper to Dynamo, where does the information go through? Does it go directly on my computer from Grasshopper to Dynamo, or does it go through?
No, it doesn't go through the web. You can be completely off-grid, and it has nothing to do with... It's not things like speckles or things like that, where it has to go through a server, or Flux, if you remember that.
The old days.
The old days.
A year ago.
Yeah. No, it doesn't have to go through a central server. You can still send things from one machine to another, but it doesn't have to be. You can literally just send things from one part of the computer to another, one program to another, and not having to worry about being connected to a paid service or whatever.
Right, so it runs locally. Got it. All right.
We're not trying to make money, so we have no interest in having things going through the net.
Well, the reasoning behind it could be up for debate, of course.
Yeah.
You could also have it go through the web and still not make money, but...
Well,
yeah,
we have the Mongo. This is why we open sourced on top of the adapters. If you look at all the toolkits we have, they're all adapter focused. But there's two that are not adapter focused. Well, they are adapters, but they're not engineering software focused, which is sockets, which is the one that allow you to send data between programs or between computers. And the other one is Mongo. And Mongo is a database system. And that's something where you can just set up a Mongo server somewhere in your company, or even just having a Mongo database running on someone's machine. And then you can use that as a central place to share data. So if you work as a team on a project, you can just have your Mongo database in one place, and everybody is going to feed into that Mongo database and get data out of that Mongo database. And then you get the same benefit as Flux, say, where everything was in one place. So that's still doable.
all right. There's probably tons of other questions out there.
Don't be shy, we don't buy it. We can
If no one-
go ahead.
Yeah, if no one else. So you're seeing no discipline bias allowed, but I assume that there are discipline-specific types of objects.
Yes. Yeah. So in those, you can be pretty biased in those ones right? when it comes to architecture. But I guess then if you're in the architecture object model, don't go in there with the sort of, oh, well, Graphics has me thinking in this way, so I have to define everything in this way. Or let me just take and in the object model, the BHoM object model, put some of their objects. That's not going to be good. It's going to be kind of what is it that they're trying to portray and everybody else is trying to portray. What's the holistic definition? And it really comes down to very interesting conversations, because even for stuff about how do you define a beam, structures guys, how do you define a beam versus a column versus a brace versus all these different things. The actual level of detail that, now we, in BHoM right now, if we work on a structures project, we use the BHoM, and there's a framing element, and that's just something that is an architectural thing. And then there's a bar. A bar is something that is analytical, and it's not the final product, but it's something that we need for analysis and blah, blah, blah. So the actual conversations that you have and splicing off, well, what goes here and what goes there? What is this stuff? What is the hierarchy? What depends on what? Once you have those conversations, like I said, you own it. You actually know holistically, when I say something to you, that I'm pushing you a bar. That's it. There's no, well, is that an ETABS bar or is that a GSA bar? No, it's a bar. Go look it up in the code. You should know this because that's the language we speak, just like we speak English, Mandarin, Dutch, that type of stuff.
Well, don't look it up in the code, just use the explode component.
Oh, that too, yeah. We'll show you the explode component.
Yeah.
It's pretty dope. And it's like Arnaud said, if you start using the code via Grasshopper and easier media, then you'll learn how to use the actual code that looks like the scary black screens that us in our industry, most people are scared of because they're like, oh, I've not been trained in that. I've been trained to do other things. So it's really low barrier to entry.
Thanks. Okay, I'm Etienne from Dragage. Okay, I like the open source idea, but as much as I like it, how can we, everyone for ourselves, develop some components that we would use for our own purposes at the scale of one company or at the scale of one project? How do we create them? How do we share them? How do we not go through the GitHub and the whole world?
And how do you not share them?
Yeah, exactly. Sorry. Yeah, how do you not share them?
That's a very honest question. You don't have to. We have no way of preventing you from just taking our code and running away with it. Obviously, we would prefer if you share back, but you don't have to. There's no obligation. And to be honest with you, there's not even a need to write code. We'll show you the custom component in a while, where it's going back a bit in a way, instead of really having something set in stone in terms of how we agreed on some properties for a component, and it's written in code. You could even just use the infrastructure as it is. There's something called custom component where you can literally add the properties you want as inputs, and that becomes an object with those properties. And that's not something when you don't have to write a single line of code to be able to use those ones.
Is that in the wiki somewhere?
I can show it in Grasshopper. That's probably just simpler. And that way you could actually work tomorrow with objects that you've agreed on paper, and then people would have to know. Then actually no, with the exploit, they don't really have to know the specific names. But I'll come back to that in a second. You write things where it's saying like, okay, this guy has XYZ properties. I'm sending that to another person on my team, and it will just explode and recover the properties. And for that, you don't need to code. You just install the BHoM and you can move on. If you want to do that, fine. If at one point you're like, you know what, the way those guys have defined a bar is moronic, I think they should be doing it differently. Then it would be great if you could, send a message back and saying, guys, this is
as much that as well. Working on specific projects, sometimes you need to have a play area where you try things, and when it's mature, we can share it with the world. But before that, you want to try things and share it locally before you share it globally.
So, do you want to go in code, or you want to stay away from code?
No, I'd say go away from code. Yeah, stay away from code.
Okay, if you stay away from code, that's the best way to use just the custom components, stuff like that. You already have some way where you're sort of coding, but you're not. So you're not writing lines of code, but you're already doing, you're already creating BoM objects. You're just not writing them in C#. So that you can already do straight away. If you want to go in code, you just can branch from what we have done, you fork from what we have done in GitHub. Sorry, technical detail, but you basically take our code, you make a copy on your account, on your GitHub account, and then you make all the modifications that you want to do, and that's yours. You own that bit. And if at one point you're like, you know what I've done is really great, you can actually take what you've done there and you can send it back. But you don't have to, and you can choose what you want to send it back and all that kind of stuff. But if you want to just stay in Grasshopper, that's possible. It will be even more possible in a few months where, as I said, I'm aiming to have a situation where people don't even need Visual Studio at all. Even to recompile the code and all kind of stuff. We already have that actually today with the code assistant. But
And you're a guy who can use Visual Studio very well, and even I see you on this canvas most of your time. when
even
you're
for my
doing
own
stuff.
personal project, I'm actually using custom objects and I'm using the BoM sometimes because I just need a place where I can just have a visual interface where I can see the object that I'm creating and all that kind of stuff. I can send it to Chrome and have some graphs there that I can interact with. And I don't want to just code something in C# where I have to create everything from nothing. So quite a lot of time now on my personal projects, if I just want to quickly hack an ID together and see if this algorithm or that stuff it works nicely, I just use the BoM because it works nicely, and I don't have to open Visual Studio either. I just literally just do it from there.
Before we go into the details, maybe a question also for Ramon. How is this, and for you as well, how does this sit in what other people globally are doing? How different and unique is this, or what are the threats that will prevent this from spreading like wildfire? Like, how do you see this advancing?
Really good one. You want to answer that one? Or?
I think what will stop people from doing it is rule number one, which is it requires a certain level of skill and a certain level of I'm taking this by the horns and I'm doing it.
No, but I mean in terms of
What other people are
I
doing.
think your question is how do we make sure that this take off and it's not taken over or is not completely
How are other people tackling a similar problem? And is anybody else coming up with an equally potentially powerful alternative solution? Or how confident are you that this is the one that's going to make a difference? And that's why I was also pointing it maybe at Ramon. I'm curious to see how you position this as opposed to the type of work that you've been doing for a while. Like what's it going to take for Arab to become BoM friendly?
I'm happy to answer that. So you mentioned Speckle before, right? And so Speckle is an open source project that kind of deals with similar type of problem space. They're mainly focusing on the data infrastructure.
Yeah.
So send it from your desktop into the cloud and then into something else. And it is I'm involved with it because the main developer now works for Arab and I'm in the key stakeholder team. And I can see actually that there's probably very little overlap with what Speckle are doing and what you're doing, but I do also see there's great potential for them to actually merge. So in terms of what Arab is doing, Arab is now doubling down on Speckle, which is already open source, and I know you guys are talking.
Yeah,
already.
I think Dimitri is very keen on making a Speckle toolkit basically. We haven't tackled that part. So on GitHub, there's a lot of different what we call repository, but it's a project. So it's focused on one thing. It's focused on linking to Revit or doing a cable net design toolkit with specific algorithms and stuff like that. And Dimitri at the moment is using his own basic geometry library, right? And he's actually very interested in just trying to do just a toolkit. Again, it's just talk and hearsay. I don't exactly know what those guys are agreeing upon, or if anything is agreed upon, but just to have a go at just trying to transform Speckle so that it can fit into a BoM format and see what it does. Because the BoM, it doesn't have to be, it's not because there's already similar solution with sockets and Mongo that we can say, oh no, sorry, but that sale has gone. It's already, that ship has sailed. It's an open competitive market. If you want to do your own toolkit and you think your way of doing it is better than the other ones, by all means do it. Do your own modules there. And I'm really curious to see what Speckle toolkit would do. because we've solved similar problems, so we never had internally, we never had the massive need for Speckle. Speckle is a lot sexier, I would say. So it's, you know, it's always something where you're like, maybe we need to do a bit of that. But and so there's never been a need for me to spend time on doing something similar or competitive to that. But I would be really interested to see that added to the whole framework and see how it can change the way people work, or even how some people would prefer working with Mongo, like probably like you, but other people would say, no, actually Speckle works better in my own environment than using something like a Mongo database. So that would be quite interesting, I think, and I would be really up for that.
Right, because the one thing that Dimitri, who is the creator of Speckle, wants to stay away from is the actual object definition. He did something preliminary that he kind of made up, but he is more interested in the infrastructure, and not so much in deciding on the object model. So you're kind of like taking it the other way around. You start with the object model as this is what an object is, and then you work some stuff around it. So potentially the BHoM object model is something that could be compatible with Speckle, and rather than sending it from your desktop A to your desktop B application, you could push it through Speckle and then receive it on the other end where BHoM is also running, or something like that.
And I think we've done, because to send data around, we're using JSON, and Dimitri is using Speckle is using JSON as well. So I think at one point, Al and Dimitri had a bit of a play with it, and they managed to do something where they were sending BHoM data via Speckle or the other way around. But I know they did some play around that, and it was very easy to just hack something together. Because they're already using JSON. Sorry, JSON is JavaScript object notation. It's just a way to transforming any digital object into a piece of string, so a piece of text, and just send it around. And we're using the same format. So I think there's already kind of a bit of an overlap there in terms of the possibility to work together.
And in terms of your question as well, I think that for some people, IFC comes to mind, as in, well, we're going through all of this hula hoops, but actually the industry already has an object model. There must be a very good reason for you to kind of like kick IFC in the nut and start to, you know, develop something which is essentially very similar, but from scratch.
Well, IFC's IFC, right? Once the powers that be get together and say, that's IFC, right? That's it, right? It's a community of people who it's a lock and key type of thing, whereas this one is anybody can come in and give their 2 cents on it, right? So, and there's no, can you actually, I don't actually know, I might be on my depth there, can you actually do what you want in an IFC file? Can you make your own UI and actually manipulate it yourself? Or is that something that no one does for a reason? Because right now, as far as I know, I would never be able to just go, I've never manipulated an IFC file just for the fun of it. Like, it's always been, you want to use IFC, you go to one of these software houses, whereas this is literally, yeah, you're right, it's the same thing. But it's not someone else telling you, hey, look, everything's got to go to this common regulated format, right? It's, guys, come on, it's everybody eventually will say, listen, it's up there. It's the way it's defined on this it doesn't have to be as it is online right now. You could take all of this down and say, I don't like the way that it is in any way, shape, or form. I don't like the way this component looks. I don't like the way this is defined. Open it up, change the 3 lines of code that it takes, and you might have just saved yourself a lot of headaches.
But that would also mean that someone else who's built some scripts based on the assumption of the object, how it was before, now someone has changed the object, that definition may no longer work.
Yeah.
So maybe it's not such a good thing that anyone can just go in and change the object.
No, the assumption is that the BHoM will converge, right? So the idea is that at the beginning, and this is why we haven't open sourced the BHoM on year 1. We're 3 years into the process already, and things are still changing on the object model. I'm not going to lie to you, but things are changing less frequently on the objects that we had on day 1. And so the assumption is that with time, some of the objects are just not going to change at all. They've been discussed so many times debated so many times that now it's just settled. And to come back on what you just said, it's not like any random person can just go on GitHub, change something and call it a day and then mess everybody else's work. There's a review process there where somebody go on GitHub, make some change on his machine, then has to submit the changes to a group of people. So anyone can review that. Anyone can review, but only a few people can say, okay, now the change that has been made here can now be merged to the central code that everybody's using. So there's a bit of a committee process there where things are being reviewed, are being debated before it's being merged, and it's slowing down. So with time, it will not change anymore. It might still have some minor changes, but it will not change as much.
And the thing is if you don't have this, it's not like you're void of this problem if you use the standard software, the standard protocols, because if something changes from Autodesk or whatever thing you're using during your project, and it's time for everybody to say, hey, we're going to upgrade, or maybe you need to go backwards in time and say, I need to go visit a project from 4 years ago, you still have this problem. At least now, if something changes under your feet, you can actually go back and say, what's going on here? Ah, okay, I can see, you can actually see the code as it's evolved since
You
2014.
can blame people as well. which is
Yeah, you
really
can
nice.
blame people with
Yeah.
GitHub, and you can go, hey, listen, you fucked up my code, and then you have the discussion of, well, we did it because of this, sorry about that. Listen, just copy and paste the code into what you got, and you're back to where you were. So it really is, again, coming back to, you are now fully in the driver's seat, and all the negatives of that, great, there are negatives, but there are a lot of positives. And in this particular case, I would say you already have the negatives, and you are without control, other than, hey, can I please beg for my old license, pay for my license from 4 years ago so I can open up an old file.
I think what we need to keep in mind with the thing that we've done here is that if you look at each piece of what we've done separately, there's nothing new there. There's object model that exists. There has been pieces of code that translate things from one part of software to another software. There's spec codes. There's all those kind of things that have been there before. And that's not what we're trying to do. We're not trying to replace that. Again, we're not a commercial thing. We're not even trying to say, you know what, commercial is bad, let's make everything free and, smoke weed every day, or that kind of stuff. No, it's not what we're trying to do. We're trying to say... We're trying to say here that we want to have the engineers and the architects in control of what they're doing. And I can see from... This is... the BHoM is something that has grew out of frustration from a lot of engineers of not being able to do their job as they imagined they would do it. Simply because they have to deal with all those softwares that are more frustration than anything else. And a few people are capable of coding, do their own thing, right, to kind of make their life easier on an everyday basis. But they're alone. They do their thing on their machine and they're alone. And sure, there are better tools that are coming every day, but those tools are just like another piece of puzzle that is just not fitting with the other ones. And it's just more frustration on just, I have 3,000 options nowadays, which is great, it's better than one, but they just don't match together. I just want the whole piece. And what we're trying to do here is this is why lowering the threshold is so important. It's trying to say, you know what if we were putting the engineers in a position where they're actually able to act on the tools that they're using every day, right? What if we create a scenario where you are as responsible of your tools as anyone else? You are in control of changing what that tool is doing for you every day. What would that give you, right? And I think that's the only thing right now that is really new compared to everything that exists. It's just saying, let's put the engineers in the driving seat. Because coding can be hard, but it doesn't have to be. If we have a few software developers that are taking care of the complicated bit of coding, of the software infrastructure and all that kind of mess, the bit that is really useful to the engineers, that's actually not that difficult. And if we could put you guys in control of that, then it's up to you to change your day and the way you're working and making it more efficient. I can't create tools for you. A lot of companies have done that and they failed. I'm still looking for a software where every person is going to say, this software is amazing and is doing everything I need. Maybe except for Grasshopper. But
No, and
maybe
people still bitch.
Yeah, people will still bitch. I mean, even on their own tool. But at least trying to make that step a bit further, trying to reduce the time you spend doing things that are uninspiring and frustrating and completely useless if it could be done just by a machine in 2 seconds, right? And just the rest of it, the creative things, you are in control of it. It's not some random software developer on the other side of the planet that is decided for you how you should do things. And I think that's the new thing. And I'm hoping that people will understand that, because if they understand that and they take the time to do the learning for being able to be in control of the bomb, I think that's where it can be quite interesting.
So maybe with that, we can, and I know it's getting late, and we've kind of talked more than anything. If any,
As
we
always.
can kind of jump into different little groups, or people, if they gotta leave, they can leave. But just thanks for coming, and thanks for your attention. And of course, we'll stick around, and if you have it on your computer, we can walk you through some stuff. We're happy to sort of do a tutorial for people who all have the same question, and take questions individually. But right now, if you wanna sort of pack up and leave, that's cool too. I know some people probably have other places to be and they feel embarrassed to leave, so I wanna give them the opportunity. If not, I see a few people with it up on their screen, which I'd be interested to see what they're doing and trying to give them some pointers. So, if that's cool, let's do it. Thank you.